any given function has more than one antiderivative. So if we look at the function sine x plus 1, sine x plus pi, and sine x minus 1000, if we take all their derivatives, we get cos x, cos x, cos x, and cos x. These constants all go to 0 when we take their derivatives. It means that each one of these four functions is all an antiderivative of cos x. So when we're antidifferentiating, what we do is we roll all these possible antiderivatives into one by adding a plus c on the end of the antiderivative. This plus c basically tells you that any constant could be there and the derivative would still be the same. Any constant would be there and it would still be an antiderivative. So in example 1, we want to find the most general antiderivative of f of x equals secant x tan x. Well, the idea is we first ask, okay, what has secant x tan x as its derivative? Well, that would be secant x. Now, of course, secant x is not the most general possible antiderivative. To make it more general, we add the plus c on the end, saying secant x plus 2, secant x plus 10 are all going to have this same derivative of secant x tan x. Just like with differentiation, there are rules for antidifferentiation which will help us find antiderivatives. Most are simply the reverse of the corresponding rules for differentiation. For example, if we're trying to find the most general antiderivative of 1 over x, the most general antiderivative is going to be ln of the absolute value of x plus c. It's not just going to be ln x plus c, and the reason for this is because ln of absolute value of x is a bigger, more general function than ln of x. However, there are some antidifferentiation rules which I'll mention explicitly. The first is the antipower rule. It says if we want to take the antiderivative of x to the n, we're going to get 1 over n plus 1 x to the n plus 1 plus c. The reason for this, if we take the derivative of 1 over n plus 1 x to the n plus 1, the n plus 1 will come down, it'll cancel the n plus 1, we'll get x to the n. Great, take the derivative of the antiderivative, we get back to where we started. The sum, difference, and constant multiple rules will also apply for antiderivatives. They're basically going to be the same as the sum, difference, and constant multiple rules for derivatives. Basically, what we can do is you can do the antiderivative of a sum or difference of separate functions separately, and if we have a constant multiplied by a function, that constant is going to stay in the antiderivative. There are going to be some rules for antiderivatives that we will not have at this time. Those are going to be the product, quotient, and chain rules. Those rules for antiderivatives, the anti-versions of those rules, are fairly complicated, and they're not usually taught until Calculus 2. So let's do some antiderivatives with these antidifferentiation rules. So the first one we want to do is f of x equals x cubed minus 2x squared plus 3x minus 7. So the antiderivative we're going to call capital F of x. We take the antiderivative of x cubed, we get x to the fourth, and put a 1/4 in front. When we do the antiderivative of negative 2x squared, the negative 2 is a constant, it's going to stay in front, and the antiderivative of x squared is going to be 1/3 x cubed. We want to take the antiderivative of 3x, the 3 is going to stay in front, the antiderivative of x is going to be x squared with a 1/2 in front, and if we want to take the antiderivative of negative 7, it's going to be negative 7x, and we're going to add a plus c on the end. We could simplify a little bit. This gives you 1/4 x to the fourth minus 2/3 x cubed plus 3/2 x squared minus 7x plus c.